Hi there and welcome to Tech Life, a channel where I aim to review everything from selfie sticks to laptops to IDEs for coding, video editing, software for producing thumbnails, essentially anything tech related. If you are new to the channel, please consider subscribing. If you have anything that you think I should review, please let me know in the comments and I'll do my best to review that product. In this short video, we'll be looking at how to handle unexpected errors in our applications. Error handling in C# is sometimes called exception handling. Exceptions are unexpected events that interrupt the normal execution of our program. So exceptions happen because something has happened in our program that we did not expect to happen. This is quite often due to an unforeseen error. Exception handling is a way or method to catch these exceptions and to handle them in a controlled manner. We have the concept of unhandled exceptions and handled exceptions. Unhandled exceptions should be avoided. We should endeavour to handle all known and unknown exceptions. Handling exceptions ensures that our application either continues to run or gracefully terminates, while unhandled exceptions in our applications mean that applications terminate ungracefully. The base class for exceptions is system.exception. So if we fire up Visual Studio, we can code up a small program that will best illustrate exception handling. Okay, so we're going to create a new project. It's going to be a console application. We'll give it an appropriate name. I'll call it exception handling. And we let Visual Studio put a skeleton application together for us, which will take a second or two. And there we are. So as always, we will get rid of the program.cs. And we'll create our own class file. And Visual Studio catches up with itself. So it's a right click and we're going to add. We are going to add a new item. The item is going to be a class. We're going to call this class exceptions. Okay, so within this class, we're going to have our system.main. So it's going to be a static. It's a static void method. Starts with a capital M and open and close parentheses. Open and close curly braces. So the first thing I'm going to do here is I'm going to put a comment and we are going to declare some variables. And I'm going to declare two integer variables. The first one is going to be called num1 and the second one is going to be called num2. Two variables. And next we're going to use a console.writeLine. I'm going to spell it correctly first. Console.write. I'm going to use, I don't need a carriage return there. And I'm going to say, please enter the first number. The reason we've got these squigglies at the moment is because we've declared a variable. We've declared two variables. We've not used them yet. The reason we got this squiggly is because we forgot to close off this, and we forgot to insert this inverted commas at the top here. Okay, so console.writeLine, it will print out please enter the first number, and I'm going to catch that number. I'm going to save the number into this variable, integer variable called num1. So num1 is going to equal, and I'm going to convert whatever's typed in by the user to an integer. So I'm going to use the keyword convert to int 32. So I'm going to convert whatever was typed in by the user, which is going to be a string, and I'm going to convert that into an integer. So I'm going to use console.read. Console.readLine. I'll explain what I've done here. Obviously, the console.write outputs to the console window, and it prints out please enter the first number. So the user is prompted to enter the first number. A number is typed by the user, and then that number then is read by this read line. Anything that's typed into the console app is going to be a string, so we have to convert that string into an integer because we've declared num1 to be an integer, and we use this convert dot to int32 to convert whatever is captured in this read line into an integer, and then that integer is stored into num1. And we're going to do the same for num2, so I'm not going to type this out again. Control C to copy, Control V to paste, and this time I'm going to say please enter the second, spell second correctly first, second number, and that's going to go into num2. Cool. And all we are going to do then is I'm going to use a console.writeLine. And I'm going to output num1 divided by so the result of num1 being divided by num2 is going to be output to the console. And I'm going to use the console.read key. Can I learn how to spell console first? Console.read key to ensure that we can still see the console app before it terminates. Okay, so that looks okay to me. I don't see any errors there. Let's see what this does. Save it. We'll do a build solution. And we'll do F5 to run. Okay, so we're prompted, please enter the first number. So I'm going to enter, I'm going to say 6. Please enter the second number. I'm going to say 3. So the output is 2. So 6 divided by 3 results in the answer being 2, which was to be expected. I am going to make this a bit more obvious, so let's just put a comment in here. Answer is, the answer is, and then it's going to be, so all I've done here is I'm going to concatenate this string to whatever the result of num1 being divided by num2 is. So it's going to be 6 again, 3 again, and the answer is 2. So I think that's a bit more legible. And that's fine, as long as we trust the user to enter the correct values, in terms of we need the user to enter something that can be converted into an integer. Let me run that again. F5. So even though I'm typing 8, that 8 is actually a string, and that gets converted into an integer. So as long as the user enters the right values, then everything works fine. So 8 can be converted into a string. 4 can be converted into a string. So we're going to get the answer 2 again. The problem occurs when the user makes a mistake or doesn't understand what they need to do, and an incorrect value is entered. So I could enter the value 8 again, but then I might enter a 0, and even though 0 can be converted into an integer of 0, we know that we can't divide by 0. Mathematically, we do get an error if we attempt to divide by 0. So in this case, we should see an exception. And so the debugger tells us that divide by 0 exception has been thrown, and this is an unhandled exception. So divide by 0 was unhandled. Okay, so that's one example of where we could have used some sort of error handling concept or technique to catch that exception, and I'll show you how to do that in a second. We'll give you another example. So if I do F5 again, so for the first number we could probably enter 10, and then for the second value, if I entered something like, if I typed in the word 2, now the word 2 cannot be converted into an integer, so we should see an exception here as well. And in this case, a formatting exception is thrown. So again, it's unhandled, and the exception that's thrown is called format exceptions. So the system.exception class contains many subclasses. One of those is format exception, and this is telling us that something's gone wrong in terms of what we've entered in terms of its formatting is incorrect. So in C# we have a try-catch concept where we use the keyword try, and within this block we place anything that we think might cause an issue, might throw an exception. So I'm going to encase these 4 or 5 lines in the try block. So what I'm saying here is try these lines of code, and if there's no issues then continue as normal, but if there is an issue then catch that exception. We catch that exception in this catch block, And in here for now, I'm just going to have a simple console.write line. And I'm just going to output an error. An error occurred. Okay. So this is called a try catch. We attempt to process the code in this area. If there's no issues, then it continues into normal. If any part of this code throws an error of some description, then this catch block will be run. Now let's see this in action. F5. If we go 12 and divide by 3, the answer is 4. That's fine. Let's try again. Let's go for 14 and divide by 0. So we expect a divide by 0 exception here, and it says an error occurred. And I'm just going to add another line of code here just to prove a point. When we didn't have this try catch and a divide by 0 exception occurred, the program kind of just fell over. The application, console application, fell over through the exception and basically terminated ungracefully. As we saw in this case, we caught the exception and we output an error. Not a very helpful error, but we still output an error to the console to tell the user that something did go wrong. And if I add another line of code here, I'm going to say console.write line. Continue to do something else. Oops. Okay, so let's see what this does. F5. Okay, 18 divided by 0. So again, you can't divide by 0. So we output a message on the console to let the user know that something went wrong, an error occurred. But we continue, the program continues. We can continue to do other things because we've handled the exception, we've caught the exception, and the program continues on gracefully. Let's just check that with our formatting exception. Okay, 20 divided by 3. Okay, so again, we've output a message to let the user know that something went wrong, but the program continues gracefully. So that's a try catch. So building on from this, the error message that we display to the user here is okay. It's an error message, but it's not really helpful. It doesn't tell us what might have caused the error, where the error occurred in the program. So we can go ahead and fix that as well. So we can pass in exception variables by adding a couple of parentheses to the end of this catch, and then using the keyword exception, and declaring a variable here. Quite often people just put E for exception. Quite honestly, you could put anything you wanted to. You could type in my exception, and it's showing the squiggly because it's saying, okay, you've declared a variable, but you haven't yet used it. So let's go ahead and use that. We can stick that here, my exception. And so now that we have this variable, there are methods associated to this, which when we use them allow us to glean more information about the exception that's been thrown. One of the most useful methods that we use is called message. So we can pick that from there, message. In fact, I'm going to get rid of this string. I'm just going to push. I'm going to just display the message that this exception is going to display for us. So if I do F5, and we're going to say 22 divided by 0, and so now we have a message that is somewhat more helpful. It's saying that we've attempted to divide a number by 0 and we can't do that, obviously. And let's try that with the formatting exception that we've seen just previously. F5 again. And if I say 22 divided by 2, and now it's saying input string was not in a correct format. So it's given us a clue in regards to what might be going wrong with this part of the code. And obviously it's a lot more helpful than just displaying a message saying, okay, there's an error. Okay, I'm going to copy this because I want to show you another quite useful method which is quite often used, and that is it's called stack trace. I'm going to put some console.write lines in here just so that you can see some of these messages a bit more clearly. Copy that. See what this does. F5. So we're going to say 22 divided by 0. So the exception.message tells us that we've tried to divide by 0, and then the my exception.stack trace actually tells us the line of code that might be causing the issue. So here, line 23, might be able to see that the exception is message that stack trace actually printed out to the console actually specifies the line. So it's saying that there's something, this line of code has actually caused the issue. So we know that to be true because we are trying to divide 22 by 0, and obviously mathematically that's not allowed. So stack trace is really useful. Quite often we use stack trace, and we take the stack trace information and we write that off into log files. So we'll use something like log4net in order to write that kind of information into log files. So if exceptions are thrown, we can go back and look through those log files to see where the issue might have occurred in code. Okay, so using a catch exception like this, and catches everything, catches all exceptions, and that's all well and good, but it's not the recommended way of doing things in C#. So what we try to do is try to catch the exception that we're expecting. So we know that there are potentially two exceptions that are going to be thrown in this code. So one of those is obviously the divide by zero, and the second one is a formatting one. So it's recommended, it's the better way of doing things to actually catch those exceptions as opposed to just trying to catch everything all in one go. So let's go and change some of this code, and I'm gonna just revert. Oops. I'm gonna rename this. As I say, more often. Stop running the code first before we change it. Okay. Come on. Okay. More often than not, people just use E here, and so you'll see that in code more often than you would. So E. Okay. Let me get rid of this. So the first exception I'm going to catch is going to be the divide by zero, and as I say, the exception class has many subclasses. One of those is actually the divide by zero subclass. So instead of putting exception here, we can put divide by zero. Okay. And now, anytime a divide by zero exception occurs, this block of code will run. That looks okay. And we're going to just push out the message F5 to run. So if we go 24, divide by zero. So it tells us, okay, you've attempted to divide by zero. And that works just as we expected it to work. F5 again. We're going to attempt to throw the formatting exception this time. So 24 and divide by 4, and now we're not going to be able to catch the exception, and because the only exception we're catching is the divide by zero exception. And let's go ahead and fix this. And the way we fix that is we can have more than one catch block of code. So if I just copy and paste this, Control C, copy, Control V to paste, and I know that it's going to be the formatting exception that we need to catch. So format, and it's this one over here. Okay, now we are catching the divide by zero, and we're also going to catch the format exception F5 to run this. And we're going to say 24, and we're going to divide this by 4 using the string 4 as opposed to typing in a number 4. and now we are able to catch the formatting exception. Input string was not in a correct format, so that gives us an idea that we've entered something incorrectly. The exception's been handled, and then the program continues gracefully as opposed to falling over and things just falling apart. And let's just do F5 again to prove that the divide by zero is still handled. Okay, so let's go for 30 this time, and we're going to divide 30 by 0. Attempted to divide by 0. Cool, excellent. Okay, so there is one last thing I want to show you. There is an optional block of code that we can add to these try-catch blocks, and that block is called finally. We use the keyword finally, and again we use the open and close curly braces, and we use the finally block to run code that we want to be run regardless of what happens. So quite often we'll put something like we'll close down connections to databases. So if we open a connection, we run a piece of SQL, we want to ensure that regardless of what happens at the end of the code, that connection is closed. So we quite often put stuff like that into this block of code. But here I'm just going to write a console.writeLine, and this block will always run regardless of what happens up here. Finally, block the code sitting within the finally block will always run regardless. So I'm going to write console.writeLine. Console.writeLine. This will always run. Okay. F5 to run. Uh, 22 divide by 0, so we should see the divide by 0 exception here. So it's saying attempted to divide by 0, which we were expecting, and then any code that we put in the finally block will always run. So we've got this message saying always run, and then when it drops out of that finally block, the program continues as normal. So we've got this continue to do something continue to do something else. So that was the divide by 0. Let's try that with a do that with the format. So F5 again. So this time we're going to say 22, and we're going to divide this by TWO2, and this time we get the formatting error, and we get this will always run, because we know that anything we put in the finally block will always run. Let's see what it does when no exception is thrown. So it's 22 divided by 2. So even when no exception is thrown, whatever code we put in the finally block, that will always run. So that's it for this short video. A quick recap on what we did. We said that exceptions are errors that occur in our code that are unexpected. We saw that a unhandled exception makes our application fall over in a ungraceful manner. We used the try catch blocks of code to encase any code that we thought might throw an exception. And we saw that handled exceptions not only allow us to capture important information regarding the exception, but it also allows our application to continue running, and more often than not, it doesn't fall over. Lastly, we looked at the finally block, and we said that this finally block allows us to run code that we wish to have run regardless of the exceptions that are thrown. And typically we would put things like closing down database connections or any open file streams we might have in the code. And we use this block of code to ensure that all of that stuff is closed down before the program terminates. I hope you found this video to be informative and helpful. If so, please do consider subscribing and hitting the like button. Thank you so much for watching. I hope to see you in the next one. Thank you so much.